All right. Hello, everyone. Last session of the day, I think, for most of us. So yeah, I have the pleasure of being your session host today. So I'll shortly be introducing our speaker. We are hoping that there might be some time for Q&A at the end. So if you do have questions, but Tice has also kindly said he will be around, obviously, after this session and all of tomorrow to answer them if we don't get to your Q&A. But yeah, if we do have time at the end, raise your hand. I'll bring the mic to you. We can answer those questions. But yeah, without further ado, let me introduce Tice. Round of applause, please.
Woo! So good afternoon, everyone. Welcome to the session where we are going to focus on tailored event monitoring, specifically on macOS, and also how we can use that to implement the concept of behavioral baselines. I'm Thijs, and I'm one of the consulting engineers based out of the Netherlands. And in my role, I'm primarily focusing on macOS endpoint security. So it's absolutely an honor to, close out the day with the last session before we can get a cold one. The sun is shining, so let's get through this, and hopefully, if there's a question, you will stick around. So what we will be covering in this session is we first take a look at macOS event monitoring, but we'll focusing on the challenge while we might not having event monitoring in place. We take a look at the options we have available and also the features, and then turning those into relevant usage examples. Then I show how to make an educated decision in what to use best in order to detect maybe specific activity across your fleet of devices. And then secondly, we take a look at implementing the concept of behavioral baselines, where we then use a scenario-based walkthrough where we are going to craft initial custom analytic before diving deep into telemetry and leveraging a SIEM. So you might be wondering what's the problem with having not event monitoring in place at all, and what's the challenge here? So let's take a look into that first. It's basically as simple as the following, thing I came up with. It's, imagine you're driving in the dark without any head or tail lights. You simply won't see anything happening until it's usually too late. And with event monitoring, we basically switch on those head and especially also the tail lights so we can see what's happening around of us. And I'm going to try to visualize and explain the challenge with a couple of basic visualizations. As we all know, a lot of activity is happening on an endpoint. Similar to the visual behind me, but then obviously on a way larger volume and scale. It's either the user or the system that's at least doing something, and without having event monitoring in place, we simply know nothing. We can't keep track of which processes or programs ran, or when a certain file got touched, as an example. Now, having event monitoring in place, no matter which solution or method you might be using, we'll get to a point where we are able to track specific events in a little bit more detail, but also this allows us to identify which processes have been invoked by a specific parent or responsible process. We know which processes were responsible for creating or touching a specific file, or we know which process was responsible for creating a particular directory. Also, if we have event monitoring in place, we can look for process executions and also can keep track of which processes have creating an inbound or outbound network connection. We can review the ports and protocols that were associated with that as well. And now another way of visualizing the challenge, I would like to show an awesome tool that two of our engineers within the Jamf Threat Labs team have been building, is the tool called Sprite Tree. And basically each dot we see on the screen here represents some piece of activity that is taking place on an endpoint. And as we can see, it's hard to track and identify them, and really we don't know what's going on the system. So you'll slowly see where I'm getting at, right? In Sprite Tree, we are going to load a very short time capture with some events that are provided by ESLogger, and ESLogger is by default installed on your macOS operating system. And by analyzing the results, you'll see how useful it is by stringing all these events together, where we can see which process was responsible for creating a directory or creating a file in a specific location. We can review which processes or programs were involved, but also the involved arguments and much more. So in this case, the mktemp binary was used to create a file in the private var directory. So first, let's take the moment to review what options we have available in Jamf Protect to start monitoring events. There are quite a few. Let's go through them. And remember, today we are focusing on macOS only. So we do have analytics, which are on-device predicate-based filters, allowing Jamf Threat Labs, but also your Jamf Protect administrators to create predicate-based rules to start track very specific user or system activity. Telemetry provides a curated stream of user and device system events happening on an endpoint. This is usually best in combination used with a SIEM or third-party solution of choice. Then thirdly, we do have unified logging, where Jamf Protect is able to tap into the unified logging subsystem to track very specific event messages that are either generated by the OS or a third-party application. Then secondly, threat prevention. Threat prevention monitors all process executions from either a macOS executable or a particular script that has been executed. And if there's a match, the execution will either be allowed or denied, and the related programs will be put into quarantine, and an alert will be generated. And then lastly, we do have web protection, which can help prevent your user from navigating to unsafe destinations on the web, like phishing, malware network traffic, or potential content filter policies you've put into place. Now, let's review the example use cases. So imagine I'm a security analyst or a security researcher, and I got tasked to collect some specific activity. I can, as an example, use analytics to monitor a specific file being created or modified. Or we can capture very specific activity where the user's keychain has been dumped using the built-in security command line utility. We can use telemetry to monitor user elevations and also monitor all the actions that took place during the time from being promoted to administrator and also being demoted back to standard. Optionally, we can also keep track of background task management items being created, which are maintaining a certain level of persistence onto the system. Unified logging, as said earlier, allows us to track very specific event messages that are maybe either generated by the OS itself or third-party applications like SAP privileges or Jamf Connect, just to name two of them. But there are many applications out there that do write really useful messages into the unified logging subsystem. Threat prevention, to block executables from being executed, but also if you would like to use your own custom indicators, you can create your custom prevent list in Jamf Protect to start blocking those applications and programs as well. And then lastly, web protection, where we can put our custom domain blocking into practice as well. So if you would like to block a specific domain, you can do that. You can add your own custom hashes there, and also, if you want to, design your own content filtering policies to block certain content categories from being accessed. So you've seen that there are quite some valid ways in order to start monitoring events on macOS and also on the mobile space. But in order to pick the most relevant one, I've come up with a workflow which can be used, and this workflow is available on one of our trusted.jamf.com web blogs as well. So as an example, as a security analyst, I got tasked to detect and monitor very specific activity. The first question we can ask ourselves, is this particular activity maybe already covered by Jamf Threat Labs, either using an analytic or maybe using threat prevention? Well, we can review that by going into the analytics and just filter down to the list of analytics to review if maybe in particular, threat already has been covered. If that's the case, cool, we don't need to do anything because Jamf already has us covered. But if we would like to, get additional information, we first can check, does telemetry provide the data we need in order to start tracking this activity? Well, if that's the case, then a second question pops up. In order to make use of telemetry, we either need to integrate with a third-party solution or a SIEM in order to start, ingest and consume those events. If we do have a SIEM in place, cool, we then start building out those queries and detection rules in the SIEM, because we can then offload the load which we initially maybe use using an analytic from onto the system back into the SIEM. Again, if either telemetry doesn't provide the data we need, or we might have not a SIEM in place, we can look at creating a unified logging filter. So if unified logging gives us the data we need, second question come in, we do either need a third-party storage solution like S3 or a SIEM in place in order to start, well, receiving those events. If that's the case, we can build out the queries and the rules in the SIEM to, well, start detecting and monitoring that activity. But again, if none of that is in place or unified logging or telemetry doesn't give us the data we need, we can fall back on the very robust analytics in Jamf Protect to start monitoring and tracking very specific activity. So we have covered the usage examples for event monitoring, and now let's take a look at how we can combine event monitoring with the concept of implementing those behavioral baselines. So for the concept, it's super relevant that both the IT and security departments are working very closely together. Only then we are able to build out those baselines in a way they are effective, but also accurate. And by mapping out known business software, it will allow security to build out those detection rules in a way they will not cause too much false positives being created either within the Jamf Protect web app or within the SIEM you might be using. So as shown earlier, many activity is taking place on an endpoint. And most of that activity is like completely legitimate. But it can be unsafe otherwise as well. In most cases, it's launchd being the parent, in some cases the responsible process for invoking other processes. But in macOS, we can also track the responsible process, which will reveal the real instigator. So as you can imagine, in many scenarios, a process is invoked, either the system trusts or we as a security analyst or researcher trust as well. But in some scenarios, it might be a process we are either unfamiliar with or even the system doesn't trust as well. So in the rest of the examples, we are going to use AppleScript, which is also known as OSA script. And AppleScript can be leveraged in many ways, but also in a way to display user dialogues in front of the user, and it also allows to capture user input. AppleScript is a binary that is being shipped within macOS by default, so it can be used by any user on the system. So in order to detect that very specific activity, we need to ask ourselves, hey, are we in our environment using AppleScript at all to display user notifications, but also capture user input? If that's the case, cool, then we need to ask ourselves, what processes do we expect to invoke AppleScript? It could be Jamf, potentially another MDM that might be invoking that AppleScript. In this case, if the responsible process, which I guess is the case for the most of the people in the room, if it's Jamf, then we might want to build out the detection rule either using telemetry in a SIEM or using custom analytics to build out the detection where we filter on those activities, but not if Jamf is responsible for the invocation. If you don't AppleScript at all, because you might be using Swift dialog or any other utilities to display the user notifications, we build out the detection rule, but leave the responsible process out of scope. So again, how does that look like in a very basic visualization? We start monitoring the execution of OSA script and then specifically dialogues that are capturing user input. But while we start monitoring that, we basically are okay, green lights if Jamf Pro is being the responsible process for that. And we might want to alert up on the fact that if it's a process that we either, didn't know or are unfamiliar with and want to investigate further on. As you can see in the screenshot, it's not AppleScript, it's Swift dialog. So the same principle that we are going to cover today using AppleScript, because it's built into the OS, applies to Swift dialog or any other dialog utility you might be using as well. If I would be an attacker with bad insensitives, I would really focus on an organization and first do a round of discovery, which dialog utilities are they using, and build my malicious payloads in a way that we are going to use those first and maybe fall back on AppleScript because it's installed by default on the OS. So in this example, we are going to detect in a very early stage where a masquerading technique has been leveraged to display user notifications. by using that, well, built-in DOS utility, which we call also a living of the land binary, we are going to, well, review how we can detect a potential attack in a very early stage. And in this example, we are going to use AppleScript, as you may have guessed it. So we'll begin by jumping into the role of a reverse or research engineer, where we are going to gather the ingredients we need in order to build a proper detection. While we have those ingredients collected, we will pass them on to the detection engineer, where we are actually going to build out that detection, in this case in Jamf Protect. Then, once we have the protections and detections in place, we are going to review a typical end-user scenario. And I guess most of us have been there for sure, so feel free to raise your hand. It was me, at least for sure. Then we are going to step into the shoes of, well, the threat actor, where we are going to do a little bit of discovery and credential access. And we will close out with being the security analyst, where we might going to review the alert that the analysts have been receiving. So let's jump into the role in this demo for being the reverse and research engineer. And today we are focusing on info stealers in general. And as, well, most of us know, for the past 2 years, info stealers have been targeting macOS significantly. And the goal of an info stealer is basically collecting and exfiltrating user-sensitive data from an infected endpoint or user. In some cases, an info stealer is just simply after the user's password, but in some scenarios, they are also after tokens being stored in the keychain or in a cache from a browser, or simply trying to dump crypto wallet currencies and upload any of that into a remote server. In order to achieve that, there are many techniques being used, like phishing, but what we also see is that more and more paid advertisements are being used to trick users to download a legitimate application from the internet while we are trying to infect them. Once downloaded, usually tries to trick the user to, well, install that application in the applications directory by bypassing gatekeeper in that regard. In the end goal, to have the user, well, execute that malicious application. Now, if you want to learn more about info stealers in general, Jamf Threat Labs got you covered with a series of blogs about that, alongside blogs that have been generated by other researchers in the industry as well. The links are included in the resources that I will share afterwards, so if you want, you have some homework where you can go through. Cool. So in order to build a custom analytic or a detection rule in the SIEM, we basically need to know what to look for. And usually we start triggering events in an isolated environment if we can. It could be either a physical device or a VM. And luckily, there are many free tools available in the community that can help you get started. And one of those tools are a process, file, or DNS monitor built by Objective-C. And these tools can help you to, well, get lots of sample events from one of your devices you might be triggering that behavior from. Another example is Red Canary Mac Monitor, which basically is backed by Endpoint security. And by installing Red Canary Mac Monitor, you can trigger your behavior on your endpoint, and you can immediately review it within a, well, pretty good UI as well. Then secondly, also Lulu, developed by Objective-C, which will give you access into network events being initiated from your device. So imagine you execute a certain program, and that program tries to communicate to whatever destination on your endpoint. You will be aware of that program trying to connect. So imagine you are running through some malware samples or trying to do your own research. If you want to know very easily if it's trying to communicate to a malicious remote and control server or command and control server, Lulu is definitely your friend. And then lastly, Sprite3, which will help you visualize a lot of events provided by Endpoint security in a very nice way as well. And the cool thing is all of these tools are free for you to use, available, and they can be downloaded from their respective websites, which are in the resources, by the way. So before we, or a detection engineer, can start building out the rule, we need to know what to look for. And as mentioned earlier on, ideally you are going to trigger your behavior in an isolated VM or an, well, isolated endpoint. And today we are going to use one of my favorite tools, which is Red Canary Mac Monitor, which can be downloaded from their GitHub. It's a code-signed and notarized application. Comes with a system extension, and it basically taps into the endpoint security framework. So I would really recommend taking a look at that if you have not any of these tools already in place. So, cool, let's get started. Let's open up Red Canary Mag Monitor, and in this case, what we are going to do is navigate into the preference window, and we are going to subscribe from all of the events that basically Red Canary, using Endpoint Security API, is able to receive, because else we have loads of data to sift through. So in this case, we are just going to focus on process execution events, because that's what we are focusing on today. While unsubscribing and then subscribing to that single event, we hit save and we can, well, continue on. So while we have set these preferences, we can start monitoring events as they come in. And for this very basic example, I'm going to mimic OSA script dialogues being triggered, but now from within the terminal, which is usually not something suspicious because it's an interactive shell that I'm opening up here. So let's just execute the command. And then once the command has been executed, we are going to put in the credentials. But as you can see, we'll get the specified visuals and text because we, well, did put them in the relevant arguments. We just provided a random value because for monitoring this activity in Red Canary Mag Monitor, it doesn't really matter what we put in that tag box. So now we can navigate back into Mag Monitor, and we can start search for the process in the right top search bar, OSA script. And in this case, we are going to review a single execution event. And by reviewing this, well, single execution event, its metadata, we can start gathering some of the ingredients we need to build our analytic. We can review the relevant process paths OSA script has been executing from. We can review the command line arguments, but also really relevant things like signing information, but also parent and responsible process information. So in my case, in this demo, we have invoked AppleScript just from within the terminal, but if you would be using Jamf and potentially leveraging a script to, well, call AppleScript, Jamf would be on the left top corner, being the parent or responsible in this regard. Perfect, now we know what to look for, sort of. We can get into the role of a detection engineer and start building out that analytic. So let's get started building out that analytic. So in Jamf Protect, we can navigate to the analytics section, and in custom analytics, we can start creating a new one. And we first need to start with filling in the basics. We need to provide it with a name, which will also be the name that will be shown in the alert section. So make sure to, well, populate a proper naming convention. Secondly, we can assign certain categories, and for now we go with visibility and credential access. Optionally, you can also assign tags if you would like to the MITRE techniques and procedures if you would like to do so. Also, the description is really relevant to populate that with useful information because that will be reviewed by the security analyst in this case as well. So if you don't provide a description, the alert doesn't have the information an analyst might need in order to really understand, hey, what happened on this particular endpoint. Lastly, we assign a severity, which we can set from informational to high. Cool. Now we will go over the more important bits of the analytic. And first we need to define what type of activity we want to monitor, in this case by selecting a sensor type. And as you can see from the drop-down menu, there are quite some sensor types available. Process events, file events, download events, gatekeeper events, and more. In this case, we are going to continue with process events as a sensor type. And if you want to learn more about what's available per sensor type, you'll see that we have inbuilt product documentation available. And if you would like to review more documentation, there's even more available in the administrative section on the left side. Now we can start building out the analytic, either using the predicate query builder view, where you basically get some drop-downs, and depending on the sensor type, you will be guided into what attributes are available by just, well, following the path. And once you become more comfortable with our data model, you'll see that you easily switch to the filter text view, where you can just build out your query by typing in the view. And that's also what we are going to use today. Cool, so let's start formulating our predicate filter. It's Apple's own NS predicate and NS expression query language. And in this case, in most scenarios for the event that we are trying to track today, we are to monitor, we are going to continue with process execution events. So as you can see from the built-in documentation, we can also start monitoring processes that are being exited or having a subtype of fork and spawn. So in this case, we just continue with event type equals 1. But we cannot leave it at this, because if we would save it as this, it would overload us our console with alerts, and simply, luckily, we have detections in place or logic in place that it will stop alerting because too many alerts being created at that moment. So we need to add an AND operator to make our analytic a little bit more specific. So our second condition is going to be that we want to monitor the invocation of OSA script as a child process. So we'll specify the process path, but to make it a little bit more specific, we take the last path component of that complete path. So instead of doing user bin OSA script, we basically just specify OSA script. This also makes, in this case, it a little bit more foolproof. If for whatever reason OSA script makes its way into another directory, we would still be able to catch that because we just care about the last path component of that path. And again, we add another AND operator. So in our organization, in our fake organization, we use OSA script still to display user notifications and also therefore generate a prompt where we are going to capture user input. But in our case, we use Jamf as MDM, and we use those scripts to, well, generate those pop-ups. So we don't want to trigger an alert if Jamf was responsible for the invocation of AppleScript. So what we can do here is basically get the signing information of Jamf signed software by using the code sign utility, and basically use the team ID where we are going to specify if the responsible process is not signed by Jamf, then our conditions are not going to be met. And the same principle applies if you're using Dialog or other utilities where you can use their signing information, or if you use another responsible process that is going to invoke AppleScript. Again, we add another AND operator because we are not there yet. In our case, we don't specifically care about just those dialogues, but dialogues in combination with user input being captured. Usually they are after your password, or it has keywords like keychain, and that's something we would like to track. So what we can do in this regard, we can loop through the array of arguments that are passed onto the execution of OSA script and basically add those string key values into our condition. So if any of those string values are within the array of arguments, the condition is going to be met. So it can be keychain, password, file vault, whatever you will put in there. If there's a match, we are able then to trigger an alert. On purpose, we did not dive too deep on the query language because tomorrow Richard Mellion, which I guess most of you know, which delivers lots of trainings for Jamf-related products, is going to host a session on demystifying Jamf Protect analytics. So if you want to learn more, make sure to join that session tomorrow morning. So to recap, we've built a detection to monitor OSA script where it's being invoked with very specific arguments, and none of the responsible processes is signed by Jamf software. Cool, so we have that in place, but well, in the background, I've created another analytic where we are going to monitor the system profiler being invoked also by a process by the responsible process that is not Jamf. System profiler is also a binary that is shipped within macOS, and it basically allows any user to get lots of hardware-related information. And in many cases, this is also used by adversaries to basically do a discovery on a device. Is it a VM? Is it a physical device? What's the serial number? And so on. Cool, now it's time to jump into that typical end user moment, and I guess like at least 80% of the folks here in the room have been here for sure. At least I have. So let's review the example from an end user perspective. This typical user uses a Mac and AirPods, and I guess as most of us has been experiencing, that experience is always not that great. So this user has been Googling around trying to improve that experience, and they bumped up on a website where they claim they have like a utility that can improve this experience. Sure, I want to improve this experience, so I'm downloading this app thinking that I can, well, improve the connection between my AirPods and my Mac. Once downloaded, the user drags and drops this application into /applications and is then able to execute this application. Traditionally, most of these info stealers kind of software is not signed at all, which will trigger a gatekeeper prompt. Because I just built this out for my demo video, it was not signed, but I bypassed gatekeeper already. So sure, yeah, the user really wants to improve this experience, and by connecting to its AirPods, they're being prompted to capture their credentials. So the user puts in their credentials, and oh, I think I need to click start. Yeah, there we go. Hits OK and closes the application. Boom, now it's a matter of believing that somehow magically that connection and experience got improved. Honestly, I have been there. Like a couple years ago, there was an app called AirBuddy. I had problems with my AirPods. I just downloaded it and installed it, and I thought it somehow improved my connectivity, but actually it never did. Again, just for this demo, I built this Swift UI app for the demo. I did not add too much logic into it, like blinking the Bluetooth icon, showing a list of connected AirPods. But if I would be a remote attacker, or sorry, an attacker, I would have put way more effort into this, well, application for sure. Cool, so let's go into the dark side now. And let's review what the threat actor could have achieved, in this case, some discovery and credential access. So the victim has downloaded AirConnect, thinking to improve his, oh, okay. We are not there yet. Give me a second. Okay. So the user downloaded thinking to improve the connection, and imagine this simple webhook listening website is our remote and control server. Now what you're able to see is that while we were executing AirConnect, it was able to capture the user password because we put that into that AppleScript dialog. It's able to capture the username, serial number, and also defined the device type. Hey, is this application being run from a VM or a physical device? So this is super relevant information for a remote attacker to have, because having your password, at least, they can already start maybe, well, getting into your account in many ways. So luckily, we've put some analytics in place, right? So let's review what the security analyst can expect in this case. So in this case, we can review the alerts because we have been subscribing to either a Slack channel or we have received email notifications built into from Jamf Protect. We'll see that on a single endpoint, 2 alerts have been generated in a single minute. So that's definitely worth reviewing in a little bit more detail. So let's review the first alert, OSA script activity. There we go. Yeah, notice the event we are going to review is a process execution event, which we have specified in our analytic. So as said earlier, the analyst can review the description, and that's really relevant to populate the description in order to allow them to understand what type of behavior has been detected. We can review the child process, which in this case is OSA script, and notice that in the arguments, there are the password keystring values that are passed into the command line arguments, alongside the flag -e or -e and the display dialog arguments. So this made us trigger the alert. Notice that also the responsible process for invoking AppleScript is in our case AirConnect, which is in our case unsafe activity because we have never seen AirConnect in our organization, so that's definitely something that is going to ring some alarm bells. We can review the signing information. Again, in our case, or in my case, this demo app was signed by my developer account, but in most cases of info stealers, those are not signed at all. So that's definitely worth reviewing in a little bit more detail. But yeah, as said earlier, we have a second alert where we can go through. So let's make sure we can review that alert as well. So we can navigate back to the alert section, and let's go to the informational alert system profiler activity. So we did not cover building out this analytic because the methodology is kind of similar, but this indicates that system profiler has been invoked by a process which we don't trust, because we only trust Jamf invoking system profiler. In this case, it also turned out that AirConnect invoked system profiler, most likely to do a little bit of discovery on the device to get hardware-related information. And this information can also be used to fingerprint the device. So imagine that password has been sent back to a command and control server. We can use the serial number in this case to basically send all those events and use the serial number as identifier for this particular user or device. But also check if it's a physical device or a VM, because in many cases an attacker that develops a malicious payload maybe is not going to continue triggering on the malicious behavior if in a very early stage we can detect that it's a VM, because why should we trigger that behavior in a VM? Because most likely researchers are triggering that behavior in a VM in an isolated environment. Cool, so I got one more for you. And remember, I noticed earlier on that we can also stream endpoint telemetry or unified logs to a SIEM, security information and event monitoring solution. So in an ideal world, we have set that up as well. So let's take a look into that. So in the beginning, I've shown the options that we have for achieving event monitoring. And as said, telemetry is one of those options we have available in our tool belt. So what we are going to do, we are going to look building out similar kind of detections, but then in a SIEM using the same kind of logic we have been discussing earlier on. So telemetry in Jamf Protect is a curated stream of events backed by endpoint security on macOS. And later this year, we will release an updated version that is also accompanied by comprehensive documentation that will be available for you as well. Telemetry is then going to provide flexibility in what type of events you would like to audit from a very extensive list of events. And then you can forward those to chosen destinations or optionally also have written to a local log file if you don't maybe have a SIEM in place, but you still want to keep track of those events for auditing purposes. Using telemetry and storing it in the SIEM helps maintaining a complete story timeline of activity per endpoint. Where if we look at analytics, it adds a little bit of load onto the system while creating each analytic, where with telemetry, we can already receive those events from the Endpoint Security API, and Jamf Protect is able to send those over to the destination you have chosen. And that will basically shift that load from the endpoint itself to that SIEM that is built for ingesting those events at scale. We have an extreme range of various events we can monitor by default. And this enhanced version of telemetry also adds the flexibility into what type of events you would like to monitor. And you can create various kind of telemetry sets where you can configure that per group of devices. And lastly, we have it all available in a SIEM where we can run queries using data from the past. So imagine we have been sending telemetry data for about a year. We can even run retro queries today going back in time. Where if you would build a custom analytic, we publish that rule, it will get on that endpoint, and it's only then going to start monitoring for that, very specific activity. So imagine we have set up data forwarding to a solution like Elastic in this case, but it can be Splunk or Microsoft Sentinel, Datadog, alongside many of the others that are available. Once we have telemetry and alert data being forwarded to, in this case, Elastic, we can run kind of similar queries where we are going to monitor for process name is OSH script and process arguments do contain password, keychain, credentials as an example. And if one of that matches, then within a solution like Elastic, we are able to review those events, from the past year. Another telemetry-based example is monitoring users added to the admin group, which you have seen maybe in the main keynote as well, and also which process was responsible for adding that user to the admin group. So in this case, we are going to run a query where we are going to specifically monitor for users being added to the admin group, where Jamf Connect was responsible for that user elevation. But it would be way more interesting to run that query where we are going to show all users that have been elevated where Jamf Connect or SAP privileges was not responsible for elevating that user. That would be way more suspicious, right? Solutions like Elasticsearch, Splunk, or Microsoft Sentinel and others have the option to create, well, detection rules in that respective solution as well. And in these solutions, we can, well, as in Jamf Protect, build out the similar kind of queries like we did while building that analytic. And once there's a match found, the analyst can review that details in a certain level of depth as well. As you can see, we can view the process executable, which is OSA script. We can review the involved arguments, signing information, alongside many more details that are available. So as shown earlier, we can easily track user elevations, allowing us to make us aware as an admin, in this case in Elastic. And once that activity is matched, it is able to, well, trigger that alert because we put a detection rule earlier in place. And by reviewing that alert, we can review all the responsible processes and the process directories, but we can also use a pre-built investigation guide. And in this case, this investigation guide allows us to basically review as an analyst what type of activity just happened within this event, but it can also open up another window where we are able to review what events took place during the time of elevation. And that's a request we had from many admins actually that, hey, we would like to monitor what the user is doing while we are giving that level of permissions and allowing them to elevate to admin using Jamf Connect or any of the other solutions you might be using. So by leveraging endpoint telemetry, you really get that complete story timeline, and you can really audit if that user did install that software or if they did do something else and abusing their privileges. And lastly, as with all SIEMs, you can build out really cool dashboards, and with some of the integrations, we do have some pre-built dashboards. You can use them as a template and also start customizing them to your organizational needs. So this is also really relevant that you can be super flexible in there as well. Just some takeaways. It's relevant actually to start to keep track of what's happening on corporate-owned endpoints. And there are many tools available that can help you get started, as shown earlier on. So at least you can then get a feel like, hey, what's going on one of my devices while you are playing around. Having this all in place helps your organization to detect threats in a very early stage if you put out the detection rules in a SIEM as an example. And as shown, you don't need to be a security expert to get started to, well, build out your custom detection rules. Jamf offers a wide range of options within the solution to start monitoring activity, but if we want to enhance endpoint security, make sure to start looking into endpoint telemetry as well, and, well, relay that back to a security information and event monitoring solution. It's a team sport, so Jamf is here to help you with that journey, and also feel free to join the Jamf Protect Slack channel on the Mac admin Slack if you want to get some expertise from the ones that are already using Jamf Protect. And lastly, I would like to make a shout out before we wrap up to 2 upcoming sessions. One, Richard is going to dive deeper on custom analytics and the available attributes, and also the query language in specific, which is happening tomorrow morning. And then we have Erin running an interactive lab while you get a hands-on experience with building out custom unified log filters. So if you have not attended one of those sessions, there's still opportunity to join them tomorrow. And if you have some additional questions, feel free to hit me up or join the Brain Day tomorrow at the exhibit hall at 10:30 a.m. Lastly, thanks for sticking with me the last hour. I see I really made it in time, so it's about to get started for the JNUC party, and yeah, have a wonderful evening. Woo! If there are questions, Adam is running around with the mic. Else, feel free to hit me up. Yay! Are there any questions? Come on, there must be one. I see you thinking over there. Do I have a question? Yeah, I see it in your eyes. The guy with the Windows machine? No questions? Ah. Okay, thanks all.